Hello everyone, today we are going to see a question on acids and bases, and this is specifically a question on a weak acid. So let us start. We have a solution of benzoic acid which has a concentration of 0.2 mole per liters. Calculate the pH of the solution given that the pKa is 4.2. So let us see what kind of information we have. We already have the molarity, which is mole per liters, and we have the pKa. And the pKa gives you qualitatively the strength of an acid. And typically here we have benzoic acid, which is a weak acid. So let us write the structure of benzoic acid. So benzoic acid, it is like this. Usually at the exam you will have the structural formula, but in this question I will write it for you. It is C6H5COOH. As you can see, we have the COOH group, which is a carboxylic group. So this is a carboxylic group, and you should know that all the carboxylic groups, they are weak acids. So we are going to write the equation like this. We have C6H5COOH plus H2O upon dissolution. Now, what is very important here, I'm going to put this double arrow, because for a weak acid I have a partial dissociation. So it is not a complete dissociation, so it will be only partial. I'm going to have my base conjugate, which is C6H5COO minus plus H3O plus. That is, I have this hydrogen which goes away. If we consider the structure of this molecule, it will be like this. I have my benzyl group, and then my carbon double bond O, and then OH here. The hydrogen which goes away is this one, so we get the deprotonation, and it gives us this molecule. So we have C double bond O and O minus. This is my base conjugate plus H plus. I can call it H plus or H3O plus because it can have an interaction with water. So either you use H3O plus or H plus, this is the same thing. Now let us see for our equation. So I'm going to take this again. What we know already is that the initial concentration is 0.2 mole per liter. So let us write this here. I have at T is equal to 0, that is initially I have 0.2 mole per liter. Then I don't have anything for water, and because water is a solvent, I'm not going to consider this one. And I don't have the formation of my product also. Now at T is equal to equilibrium. When I achieve equilibrium, suppose we say we have X mole of this base conjugate which is formed, or X mole of H3O plus which is formed. If we use a constant volume, we can still use this relationship, because let us say that the concentration here it is X, this one it is X. Based on the stoichiometrical ratio, we will have 0.2 minus X here. So it is 0.2 minus X, as you can see. And this one, it is for the concentration at a constant volume, of course. Now, we have the pKa, and then we have Ka. What is the Ka? Ka, it is, as I said earlier, it is a qualitative figure to infer about the strength of an acid. But what is the quantitative aspect? It is the products upon the reactant, concentration of products upon reactant, so it will be C6H5COO minus times the concentration of H3O plus. I divide by C6H5COOH. Now I can replace directly in this equation, in this expression. It is X times X divided by So x times x divided by 0.2 minus x. Now, as you can see here, we have the Ka, but in the question we have the pKa. It is very easy to change from pKa to Ka. So we have the pKa is equal to negative log of Ka. This is something that you need to know. pKa is equal to negative log of Ka, and I'm going to write pKa is equal to negative log of Ka is equal to 4.2. Now, it is a logarithm. It is to the base of 10. So, log of Ka is equal to minus 4.2. Ka is equal to 10 to the power of minus 4.2. I can leave it like this. Now, let us plug this value back in this expression. So, I have x times x, which is x squared, upon 0.2 minus x is equal to 10 to the power of minus 4.2. So what do you notice here is that it is 10 to the power of minus 4.2, and we can do a small approximation here because this is a very small number. So the approximation we are going to use here is, you can use it at the exam also, and it is recommended in the mark schemes. We're going to say x squared divided by 0.2 minus x. It is almost equal to x squared upon 0.2. So I'm not going to consider the minus x here. And this one, it is equal to 10 to the power of minus 4.2. This way, we don't have to solve the quadratic equation using the discriminant, etc. Now, I have my x squared is equal to 0.2 times 10 to the power of minus 4.2. I can just take the square root of this number. I obtain 3.55 times 10 to the power of minus 3. Now, what is x here? X, it is the final concentration of H3O+. This is what we obtain here, x of H3O+. We need to calculate the pH, so now it is very easy. I'm going to write it here. The pH is equal to negative log of the concentration of H3O+, the final one. And this is what we obtain here. It is negative log of the concentration of 3.55 times 10 to the power of minus 3 is equal to 2.45. So this is a way we can solve this question for a weak acid. And this is what is different from a strong acid is that we have a partial dissociation, and for a strong acid, I'm going to show you in another video. For a strong acid, this is even more simpler. So this question, this technique, you can use it for your A level or your IB level, or even I have seen students for general chemistry in the first year at university. It is very common that it is a classical question. So I hope you enjoyed this video, and if you like this video, just you can like this video, and if you have any questions related to acids and bases, you can ask me in the comment section below, and I will try to answer it at the earliest possible. So until then, bye bye.